So this video is going to go over the introduction into limiting reactant and excess reactant, looking at a chemical reaction and what's given in the problem and drawing a particle picture to kind of figure out who is your limiting. So in this problem, I have 2 sodiums plus Cl2 goes to 2 NaCl. And I am finding that in this problem, I have 6 moles of sodium and 4 moles of chlorine. So I am going to draw a particle picture at the beginning of the experiment versus at the end of the experiment. And sodium I'm going to draw as an open circle, and Cl2 is going to be closed in circles. And again, it's diatomic, so I need 2 circles touching. So I was given 6 moles of sodium. So I'm going to draw 6 circles here of sodium. And again, I'm not going to worry about states of matter in this case. I'm just trying to see what I have, enough building blocks essentially to make my product. So that's why I'm using this. And I was given 4 moles of chlorine. So I'm going to draw 4 of these in the box at the start. So at the start, none of these are reacting quite yet, but then time progresses and you start to get a reaction. So I have 6 of sodiums and 4 of chlorines given in the problem. So now I'm going to combine them to make NaCl. So I'm going to try to make as many NaCls as I possibly can. So I'm going to take all of 6 moles of the sodium, and what you're going to see is when I draw each one of these, I'm going to use up all 6 of these, but I'm only going to use a total of 6 individual Cls to make NaCl. So what I have is an extra or an excess 1 mole of Cl2. This is an excess, meaning it's left over. It's not completely used up in the reaction. So this particle picture shows you exactly what we have in chemistry, meaning we have something that is limiting us in how much product we can make, and then we have something that is going to have extra left over at the end. So this is called the limiting reactant. This is called the excess reactant in this example. So let's answer these questions, and I'm going to show you how you're going to use something called a BCA table in more complicated problems. So I could produce 6 moles of my product, okay? So that is the sodium chloride. So those are 6 different moles here that I have created in my picture. My Na is my limiting. My excess is Cl2. I have 1 mole of Cl2 at the end of the experiment that I drew in the box here. So I'm going to be, not every problem is going to be nice, easily drawn, and you have nice numbers. So we're going to have to use something called a BCA table. And B stands for before the reaction starts. C stands for change. And A stands for after the reaction has taken place, so at the end of the reaction. So it's kind of the beginning and the end, but what we're adding in the middle is what is changing in the middle in this process. So I'm going to write a BCA over here on the left, and I'm going to write the balanced chemical equation on top, so I know what things I am talking about. All right, so at the beginning of the reaction, I have 6 moles of Na, and I have 4 moles of Cl2. Okay, that was given in the problem at the beginning. Okay, so at the beginning, I have no product, and that's going to be pretty much the same on every problem that we do with a BCA table, is you start with reactants and you have no product. You could also do the opposite. You could start with a product and work backwards, but again, this is going to be the basic setup. Then change happens. So I have to take the sodium and the chlorine, and they have to be, the chemical process needs to take place. Bonds are broken, bonds are made. And so on this side of the reaction, you're going to take away from those moles and make sodium chloride. And on this side, it's going to be a positive. So this is not math class, so I'm not subtracting from 0, so I have to be adding to 0 on this side. So in this type of problem, we are looking at the number of circles that were used up. So in this case, all of the sodium was used. So that's 6 moles was completely used up. And the chlorine, I used a total of 3 of those moles. So I had 1 left over. So I had 3 of them that were being used to make the sodium chloride. And always with your limiting reactant, that's the one that's going to go to 0. Okay, so one of these, either the one of the reactants will always go to 0, the other one you will always be left over. So this is your excess reactant in the problem. So we're only going to be dealing with 2 components in a balanced chemical equation. You can have 3, like in our s'more example that we talked about before, but in most cases, you're going to have 1 limiting and 1 excess reactant. Now, the key to this is the limiting is going to essentially determine how much product you make, okay? So in our example, again, I had to depend on the sodium circles. That was going to be the one that's going to limit how many sodium chlorides that I made. So that is why it turned out to be 6 moles. Now really in balanced chemical equation, it is because I have 2 sodiums for every 2 sodium chlorides. So when we get to more complicated problems, you are going to have to look at the balanced chemical equation. But this one turned out real nice because it would happen to be the same number of moles on for the sodium and the sodium chloride. So this is, again, our basics of what we call a BCA table. And again, with all of the problems that we're going to do, it's just a nice format to kind of organize your information,